Всем привет. Собственно, во-первых, большое спасибо, что пришли.
Okay, hello colleagues. Thanks for coming. It's my pleasure to talk to you at this big and important event. I'd like to share with you a really interesting topic, which is somehow in the shadow. This is about loads running from memory. Here is how it happens. About 3 months ago, I started writing an article for Harbor, how you can execute without files. So those who have learned or passed the OSAP exams, they know this. But we don't have enough materials, we want more, and we understand that the green antiviruses can find this. And I needed a universal tool which would let me stay undetected in terms of our payload. So I researched this to find that the texts are also determined by the memory region we penetrate. And this is what I'm going to talk about. So if we haven't met before, this is no good. My name is Misha. I'm completing my first year of education in the Ural Federal University. I work for the MTS Innovations Center, Cicada 8, and I'm trying to promote our Russian internet security. In Russia, I write articles for Hacker, for Harbor, and I have a small Telegram channel, and I like Offensive Positive. Okay, let's talk about these memory regions. What are we talking about and how to deal with them? Well, you know, memory is a segmented thing. It is segmented into 3 major regions: private, mapped, and image. And we can have a look at these regions through the process hacker, and we can see there the type. Okay, what is the type? I don't know. And so I have a look, and with trial and error, I understand the following. Well, private. Well, private is a private memory, which is given through the MU, virtual logs, and other things. Mapped memory is something like if you open a Windows-related reference book, this is a special memory where this file can be mapped, and then it can be doubled in several processes so that they can use the same file at the same time. And image is about PE files, DLLs, exec files, and so on. Okay, what does it look like inside? Any region is described, so we can get the information using this structure. So we can use memory basic information or memory region information. And you can find it through the virtual query, it's under the hood, and so on and so forth. So I think you can get it. Okay, how does it happen? So you can call the mixture virtual address function, and you can use the PTE and other structures to obtain this information. And in our terminal mode for the pin tests, so we don't go that deep, right? Now there are 2 options for us here. Either everything is going to work out and the antivirus will shut up, or the host will go to the, well, not work properly. So we should go from the user mode without editing anything. But if you edit it, you do it really kindly. Okay, how do we secure memory for the region? So for every region, we have some specific authority or privileges for reading, for recording, for executing, and so on. So the mapped region usually has read-only, and the private has read-write. But even Firefox has a read exec memory. This is an anomaly, but we'll cover it later. Okay, how do we go to the private regions? The easiest way to get there is to allocate memory using these functions virtual alloc, hyperloc, malloc, commit interface, and so on. The right part shows the shellcode runner, which lets you bring the payload to the private region to run it. We try, we launch it, and we see that, so this is a calculator. So our payload is in the private region. We have the executive memory, and the shellcode is run. Okay, let's go further. Well, this is not serious, is it? This is funny. Well, any antivirus will find it. Okay, what shall we do about it? We should look for the things they don't like. Okay, they have a look at the virtual log, they hoop this stuff and test it, and they say that this is not legitimate or not typical for a company, for some application. Okay, then I take Moneta, which is a leading open source memory scanner, and I attacked my running application with it. So this is a simple detect. So it means that our exe file doesn't have a digital signature. Well, this is not a big issue. We can steal it from DCS. You can buy it, and so this is not an issue. And the next detect abnormal private executive memory is a serious thing. So it means that executable memory is not typical for the abnormal private. So where do we draw these interesting conclusions from? Well, from time to time it has false positive detects, and I check it through the VMware. So I write this payload on the machine and then send it to the share. So we have the runp from share and a mismatch. So what does it mean? It means that the process environment log information doesn't match what we have on the disk. Well, I think that a year ago we had a speech. So the guy went around this green antivirus by changing web, but now it has been detected. Well, this false positive causes some unusual behavior. So I launched my payload and Moneta, and I see many detects from the legitimate software. And here is my conclusion. So the defect of mismatching is not the core one, which lets the antivirus say that this is malicious software, let's block it. Okay. And remembering this beautiful detect abnormal private executable memory, so I tried to use this for gathering some statistics. What kind of memory and what kind of protection for the region is typical. Okay, here is a little application I wrote, and here is the data I got. So the image of the region, in the image region, we have read and executable memory. So this is the only region where we can execute. This is a very important hack, and you should remember this, because in the image region you can really be parasites, and we are less likely to be blocked versus private or mapped. In private it's read-write, and for mapped it's usually read only. Okay, I decided to show all the ways to get and execute code from various regions, including the mapped memory. To inject into this memory, we need to call some APIs to create a file reflection, then you push it somewhere and give it the control flow. So here you can see the shellcode runner and the file, but this code is, so here is a small GitHub repository. I made it public half an hour ago, and here you can see all the examples of the codes I have in my slides. And the next way to inject this region is called mapping injection. So we will also abuse these legitimate APIs, both high and low level ones, to inject the shellcode in the mapped region and execute from it by taking over the control flow. We have local injection, so we inject a running process, and we can also run remote injection. So we can, in fact, a third-party process. And to do remote injection, we need lower level analogs, which entails some restrictions. This is not typical, this is unusual, this is not right, and so on, but we have to live with it. So we launch this, and we get the read-write executable memory region where we can run our stuff. Here we have Moneta, and again we have the text. So it means that for the image region and for the mapped region, executable memory is not typical. Well, this is something we all know, but here are some statistics to confirm this. And I think that I can't but mention one interesting way. Well, this is a way to reduce your payload detection rate when you use remote injection. And this is a read-write executable mapping. It means that in the address space of our process, we show the read-write payload, but in the address space of the attacked, we show read executable, and this will reduce your kind of profile. Maybe your shellcode will stay in the memory for a little bit longer. There is another way to get to the mapped region. It is called the instantiation callback. By the way, every 10 minutes, all the TVs will show the QR code you can use for asking the question. Maybe I will answer the question, but if I don't, you can text me and I will try to answer your questions. So this instrumentation callback lets you inject this through the syscall process, proof of concept. So here is GitHub, go to researcher, and this is the code for implementing this attack. Okay. We have dealt with this routine regions, and now let's talk about the image region, which is the only one who has executable memory legitimately. And this is really exciting because that's where we will inject our shellcode. So we'll launch it and we'll see the internals of it. So process hacker memory. So you can see that all the files are mapped as executable memory. So we need executable memory for our shellcode. So we need to make it to this region. How are we going to do it? There are many interesting and unusual ways for this. And the most simple ones is to call this create file mapping. Then we have some attacks. Then we can use another file through file mapping, and we can also use function stomping. We can abuse the conf factoring hook, and we can also do some DLL overlogging. Okay, what is memory module? So the Windows loader somehow shows load on the memory. So DLL and PL files, and the memory module is the same thing, but done by developers, by us. There are three big ways here. So we start with fancy code and all the way to Blackbone, which supports the e-injection into third-party processes. And there are two interesting things here. So one of them can show the target library in the private memory. So we launch Moneta, and we see the detect called abnormal private executable memory. And the other one injects into the image of the region. And the detect is the mismatching PEP module. This means that there won't be any entry on this. Okay, no entry. We add the entry. We mismatch the PEP module, and so the information in the PEP is different from what we have on the disk. But we have a no file execution. To avoid this, we need to add a file on the disk, and then it will be fine. Well, this unusual behavior is cool, but not so cool on the other hand. Well, ideally, if we consider the memory module in the context of the less detectable way of injection, then we should go to the image region, and apart from that, we need to add entries to PEP. And remembering that we have a lot of false positives, we can conclude that our payload is not going to be easy to detect. Okay, create file mapping. This is a legitimate way to make it to the image region, and you can have so you can map the files, and we have the valid PE file, which is one of the conditions to follow. So if you try to map not a PE file, then the function will return a mistake. But you can spoof it. Well, just a few bytes can be replaced, and the payload goes to the memory. The advantages: we get to the image region, the executive memory is there, no text for this, but we don't have information that our payload in the PEP, and detected that we don't have the file on the disk if we add something to the PEP. Here is a code sample how this can be done. So the GitHub repository has all that. We can launch it. That's great. Our file is mapped in the image region. We have the execute bit, so we can run. Okay, great. The same function with the sec image no executive flag. Well, it is quite unusual. You can make it to the image region without calling the kernel callback. So the antiviruses see this, and they can understand the unusual behavior in the system. This flag can avoid calling this kernel callback. So here are the documents, and you can see this written in black and white. Okay, we can run this from memory, and this is used for some non-standard unhook libraries. So this is just like sec image mapping. Okay, function stomping. This is quite interesting. It is a little bit more tricky, and so we can have mapped memory, and we can re-record the address of a given function in the library, so we can add our payload. So you can do some local injections and remote injections, and we need to find a library we are going to inject.
Вообще без проблем. Все что угодно, все что не сломает вашу программу, то вы можете.
Well, you can do anything. You can record anything. Maybe you are not using COM. You can record it. You can put there the shellcode, and everything will work finally. You can also use. We can get the address of the function you're going to infect and to rewrite. You can use the get proc address, or if you go to the GitHub repository, you can find the same process res project. So this is to use debugging files to understand the addresses of the function. Then we need to change the memory because there is read executive, but we need to read write. So you just copy for this address of the function of the shell code and give this the control flow. So remote eject, we find the library, we find its address. All the libraries there have one base address, so you need to find this, and so you give it the control So, well, create remote threat. Well, this is peanuts, but well, you can transfer control the way you like it and the way you find safe. What are the detects? And okay, this is a different story. Modified code. So Moneta can understand that we have changed the code of a library. So we just dumped the function. This is quite interesting. I started researching this. How come this detect is there? I go to the Moneta code and I find an interesting attribute called shared. Okay, it's not related to a map and we don't have the region. Okay, let's continue. So all the changes in the text show this modified code detect, and I was uncomfortable. And there I saw the K32 query something call, and I called this memory allocation types. So Windows doesn't always map libraries. It just once shows the image of library in the physical memory, and then it sends this to the same library to the virtual spaces of these addresses. What do? We write the code of one function in this library, then we do stomping, and one flag called shared memory. Between these three entities goes off, so this becomes private memory. And this is what the detect was based on, but it can be bypassed. The next attack I decided to mention is called com function stomping, and it helped me a couple of times. Well, those who deal with comms, you know that it's difficult to get the com object pointer. It is based on fabrics. And we can rewrite this instance flow in such a way that it will go to our shell codes. There we hook one function and it will give us control. But there are some disadvantages here. This only works with comms which are written on DLL files because the XF files are mapped differently. And if in the target app you have some co-create instance, then this hook is not going to work. The next attack to make it to the image region is called DLL hollowing. There are many implementations of this attack, and I think that the guys got confused. At least they got me confused. So there are some simple ways. You just change the address of the entry point. And you can get to private, to mapped, and to image. And here are the detects. For private or mapped memory, we need the executive memory, which is not typical. This is abnormal. And we can also have the modified code. If we make it to image and rewrite something, then we have this modified code detect, which kept me awake at night. Because Moneta somehow understood this. I didn't know how to bypass it. Model overloading, a little bit more sophisticated. Here we record the whole library in the memory. We just replace it one with the other one. So we have proof of concept of this with Scheherazade. Well, this is not rocket science. You just get the library address, and this works pretty well. And now we are talking about a really interesting thing to bypass this code modified, and it's called phantom hollowing. It means it is based on the so-called NT transactions in Windows. It was shown in our community by an attack, and so they establish a transaction, they create it, and then they add the file we want to in fact, say ntdll. Then we write the shell code. We call the API write file. So the transact can be used through the read file so the Windows APIs. Then this handle went to the anti-create section. This created a section. Then the file space or process was mapped, and this way we bypassed this modified code detect. And so for a store, is also the author of Moneta. We also have this in C# and so on. Okay, here are the artifacts.
Если мы не используем TXF транзакции, то опять-таки modified code detect.
If we don't use TXF transactions, so we start it's modified code, and here we start running this, and we can see that we don't see any modified code. So it's looks fine, but we find a new detect phantom image, and this is a new challenge. What to do? Okay, the previous detects like missing modules, so they are quite simplistic. So you can add things there. You can add to PEP information. Okay, what is phantom image? Phantom image is based on the fact that the transactions are isolated. So you cannot impact a transaction from a different process. And Moneta tries to gain information on the file,
И у нее это не получается, и она
which is mapped in the section. It cannot do it, so it says that it's not what it should be like.
в клаве поднять.
So you can try to write this code, and this way you'll have a handle for the ND file which is mapped to the section. So these transactions are isolated, and this will cause return a mistake in the function.
Как это? Очки вредоносу добавить в том, что
So this will mean that malware is not behaving properly. And there are many people
внедрили как-то.
facing this issue. Okay, they injected properly, and maybe it was not detected in the past, but they forget that there are some differences in the way the file is mapped and what it has in the PE structure. Since for every section of the PE file you have the standard extension, so executive or read-only for resources, for instance.
Внимание на то, что
You should also pay attention to the fact that some people have MD, MZ headers in non-image regions, which is also an anomaly. This can be also detected, and this way our payload will be blocked. It can be easily bypassed. These headers can be
по адресу. Но опять,
removed, but it's like a race. Either you will erase them quicker, or the antivirus will block you. You can also have some floating codes. You can analyze the telemetry of the stack, bypass and push things, erase things, but this is beyond the scope of our discussion. You can have fibers, and so there are thread pools and fibers, and so. But for this, you use exotic APIs, and it causes other issues. This slide shows a picture showing the stack telemetry. The return address is not clear, and this causes a defect.
смотрим дальше.
So looking forward, I found that .NET processes
Так скажем,
have an unusual kind of behavior based on that domains, application domains exist in C# and .NET. And this, in fact, a process within a process. So that it should be supported, you need to allocate memory. So for .NET process, if you put Moneta there, you'll see a picture like that. This is PowerShell. This is a PowerShell process that runs Moneta, and you get this exact memory. The problem is well known. It's been solved, or at least some actions have been made. For instance, those who can see, you can see that I've put this filter there, CRPWX. But it does work. I don't know why. You can read in more detail about this mechanism here, and this one is, this scanner is a bit more intelligent than Moneta, that allows detecting such outlier behavior. Also, let's be frank, it's quite dull. Not enough that you need this inject process, you need to have some process, you need to prepare the workload, you need to test this. But can we do it faster? Yes, we can. Actually, you can allocate memory without using virtual locks. In particular, this slide shows the function that allows generating read-write memory by abusing this JIT compiler. Also, there's a simpler way that's based on abusing the delegate mechanism. I guess everybody knows the function get delegate for function pointer. It's based on you placing a code somewhere and you need to create a delegate. But there's a reverse function, get function pointer for delegate. It allows getting the address of the delegate. Look at the logic. Firstly, we create a delegate. Of course, it's non-executable, so it has executable memory. It's good. Then we get the delegate's address, rewrite the information, the delegate code, the shellcode in this case, and then we get the address for it and create the delegate again, call it, and this leads us to being able to run our shellcode. So this presentation is a kind of compilation of what I've learned through the research of effective execution. I'm hoping that this presentation will help one way or the other with OSIP classes. And now we're passing to the questions. And by the way, questions from the room are not approved, so please write here for me. With all my respect to you, please use this method for asking questions. So, how often do you get access someone else's image in the memory to inject your shellcode? Usually you need access to the process and well, a good question. But again, analyzing that in Windows, everything is quite right in Windows. So one way or the other, without having some privileged accounts, you won't be able to get to anything the process run by the current user. But for click and handle, I forget. I had a paper on Hackett about that. There's another attack that allows getting this handled from somebody else's processes. So from time to time, I have a checker. From time to time, you may get privileges, high privilege by abusing the get the credentials by abusing the privileges. When they're saying that the AV stalls the process, can you emulate code? Yes, all detects related to reflection and fileless execution are in runtime one way or the other, because without running the exe file, you won't be able to understand what's happening there.
Вопросы надо по QR-коду писать, а не в Telegram.
Please ask your questions using the QR code, but I'll answer. Yes, all the code examples are available. There's a link to GitHub. You can open it and see all the code that you've seen the slides. Nevertheless, if you lost the link, I will share this presentation and it will be publicly available as early as this evening, I hope. I'm sorry that I'm not using the QR code, but I will read out my question. In the presentation, you noted that .NET collects a lot of detects during a memory execution. If you use call win in the execution and add the process of build, will this help? Attach in the context, you mean to put it all? Yeah, but that's a huge detect. It's an emergence of a .NET environment in a non-.NET environment is a red flag, is a ban, is about blocking. But if you use it, well then,
Наверное, сработает, кстати.
perhaps it will work.
Попробуй.
Okay, accept it. I'll try. Okay, yeah, curious. Oh, I've got lots of questions arriving. How possible it is to be implemented in the wine environment under Linux? Well, yes, perhaps it's possible, but why? I've never tried it. How to protect the process memory image? Well, memory cannot be protected, I think, in principle. Well, how? You can actually install PageGuard. I'm talking about the user mode. I haven't studied the kernel mode. You can put PageGuard,
Что кто-то пытается получить.
or you can some other tool that will notify you about somebody else trying to get access to a page. Enable comparison of hash sums. But how can you get a hash sum in memory bytes? They're changing all the time. There will be changing happening. And again, it's not stable. It's not standard. There are all these offsets, as a colleague here mentioned.
Так, рассматривали, да.
Have you considered? Yes.
Вы говорите, что
You're saying that shellcodes injected in the image segment are not detected. Why is it happening if there are recommendations for developers to detect such codes? Well, they are detected, but it's a combination of factors. You can't just say, so hey guys, inject your codes in the image regions and you'll be tip-top. No, rather, there's a whole combination of factors is required.
работать. Попробуйте получить доступ.
So try to get access to LSAS and everything will get broken.
Рекомендации для разработчиков.
The recommendations for the developers of AV solutions.
Это прекрасно.
Moneta, seriously, Moneta is a great open source tool. To open a code is quite easy to understand even for a 19-year-old student. To add some static things, some static rules with dynamic analysis, and it will run perfectly.
Как определить?
How to determine the dilemma functions if the debugging symbols are not available? Well, if they aren't, and again, if the function is declared exportable, the stomping function allows rewriting any function. The important thing is that you need to find the address.
Shellcode через .NET
The shellcode
.NET процессов.
over .NET Delegate, does it work only for .NET processes? Yes, indeed. There were examples of code. I don't know if the presentation is still available. Oh, yes, great. This is an example of C# code. Well, I don't know if you can create delegates from C++, but perhaps it's not. But if it is, it can be done. Okay, for any .NET process. C#. Process ghosting, have you considered that? Well, process ghosting is a bit different. If my memory doesn't fail me, you had an exe, and then you set some attribute that allows you to do delete and pending. But again, it's about something different. It's not about execution in the memory. It's more about hiding the process.
Ты также упомянул про virtual.
Okay, you've mentioned virtual protect and mentioned AV not being happy about an attempt to exit the segment. Well, yes, it can stand in the way. So these hacks, as I'm rewrite executive, help us quite often. Can one get access to the memory kernel from a regular user, not an admin, to the kernel memory? I mean, the physical memory, no. From user mode, no. Without admin permissions, well, maybe only using some exploits. I don't know.
Ты сказал, что одна либо...
You said that it is either mapped in the memory once, or what if it has some changeable area in the memory, which changes for all the all the processes? Well, what's the changeable map region? So it has been mapped. It's been passed to the virtual address space of any process, and what it needs, it changes in itself. Windows plays no role here. It takes and changes what it needs. Well, frankly, I've never encountered things like that. It looks like quite non-standard behavior. Why would the library need to rewrite anything inside itself?
Да, кстати, тут...
And by the way, it's the third question about antivirus statistics. Well, as you understand, no brand vendor would tolerate if I say that we have been able to bypass them. I have a mortgage to pay. I have a wife to keep happy. So, well, that's basically it. So these are my contact details.
Как-нибудь потом найдете, если что, прямо сейчас можем обменяться. Вот.
Okay, thank you all.